I think we are live. Yeah. All right. Hello. Welcome to this week's Vercel Community Live session. I'm Amy, your moderator for today's session, and I'll be joined today by the Fluid Compute team. If you feel comfortable sharing where you're listening from, please let us know in the chat. Of course, feel free to share any comments, questions throughout the session. Before we begin, I just want to remind everyone of our community code of conduct. You can find that linked up in the site nav and down below in the footer. And let's just continue to keep this a positive and respectful environment for everyone. And with that out of the way, let's welcome Mariano, Doug, Craig, and Javi here to talk about Fluid Compute. Guys, welcome.
Hello.
Hello. Good
Hey, everyone.
afternoon. All right. Where shall we start? Shall we do like a quick round of intros? My name is Mariano, product manager for compute here at Vercel. Now, Doug.
Oh, I'm muted. Classic. Nice to meet you, everyone. So I'm Doug. I'm one of the engineers who worked on Fluid and is responsible for our new Fluid compute. I pass on the baton to Javi.
Hello, I am Javi. I'm a software engineer here at Vercel, working as a tech lead in the compute team, and I also worked on Fluid Compute. So I pass on to Craig.
Yeah, I'm Craig, another developer who also worked on Fluid Compute. For the last about 2 years we've been working on it, I think,
Yeah, constant evolution. So it just goes on forever and ever.
Nice. Yeah, I think like that really summarizes what Fluid is. It's been like a constant evolution coming from servers up to today. So I think like that is giving us like the right cue for you, Doug, to start the demo. And
yeah,
talk about it.
Yeah, so I was going to start with a quick demo of what Fluid Compute is, and specifically like contrasting it with traditional servers and with this kind of traditional serverless model. So hopefully everyone can see my screen. But what we have here is like a little demo that kind of reflects how servers work, and I'll flip between the different kind of, I don't know, paradigms, whatever we want to call them later on. So you can see I have a server running, it's always on. And you can see that it has like, I'm accruing usage the whole time, and that usage is what I'm paying for. So whenever I have a server, I'm paying for it being on. If I send requests to it, you can see these funky little bars come in. You can see the sort of amount of CPU time and idle time that each request is doing. I will say this is kind of like somewhat reflective of what happens when, on the Vercel platform, when people make requests. A lot of our hosting is like Next.js apps. And when you send a request, it's going to do some CPU intensive work at the start to like route the request, pass the data, etc. That's typically followed by something like a database call or an API fetch, something like that, which is IO bound or idle time. So it's not actively using the CPU, it's just waiting on like external resources. And then finally, once that IO is finished, we typically see some like short period of rendering time. So these requests that we're sending here are kind of representative of what we typically see on Vercel. And I mean, when I say on Vercel, I mean like, all the people who host their applications on Vercel. So this is a very typical like pattern. So with a traditional server, if I send a bunch of requests all at once, what happens is if I send too many, my server becomes overloaded. And you see this kind of slowdown effect here, where you're trying to use too much CPU, my server can't handle it, and as a result, everything runs even slower. And again, just to call out, I'm always paying for this. Now, if I flip to a serverless model instead, serverless works differently. So fundamentally, like as I send requests, the traditional serverless model spins up small isolated VMs, micro VMs, and those micro VMs handle like one request per instance. So you'll see if I send a request, I get a new instance. If I send multiple requests, I get lots of instances. And contrasting with the server model, the usage I pay for is the usage of every single one of these. So if I have many things running simultaneously, I'm paying for like the sum of all that time. So if I flip the two together, I can't reset the usage, can I? Yeah, anyway, that's that's kind of that. Yeah, what you'll see is if I send a lot of requests, this usage as well accumulates a lot faster than the usage of servers. So that's where, like, I don't know, some people complain that the serverless model can become quite expensive. Now, where fluid compute comes into this is it's a hybrid model. So it's kind of a best of both worlds. And what I mean by that is the isolation that serverless model of having, our request per micro VM isolated is no longer the case in Fluid. So if you see I send many requests, they can run in parallel on the same instance. But if I send too many, it will spill over into a new instance. So if I send lots of requests, you see there's no CPU slowdown anywhere here. But also, I'm not having this really expensive thing that I had with serverless, where if I send lots of requests, I require lots of instances, and therefore my usage skyrockets. So in that sense, yeah, best of both worlds. That's, in a nutshell, what Fluid is.
Yeah, and I think something important to remark here is why did we go from servers to serverless? What was going on with serverless and why we end up on Fluid? Something that has been happening traditionally in the industry is that we've been optimizing for serverless workloads. We've been optimizing for tasks that are fast, tasks that start and finish quickly. We've been optimizing for microseconds with databases. We've been optimizing for everything running really short time. What happened? Then AI disrupt the industry. And when we started getting these new workloads, these AI workloads, now we might want to have long-running requests. We might want to give the models time to think, time to reason, however we want to call it, time to compute in the background. And serverless basically become an almost broken paradigm for that. Why? Because the more time you are waiting is time that you are paying for that instance, you are allocating that instance, and you're not actually using the CPU that you are paying for. You are just waiting for something to reply to you, to start streaming, whatever. Let's think about like a really classic use case. I have my own chatbot that I implemented that is wrapping OpenAI and just hitting their APIs. I will hit my API route. It will run something like pretty small, and probably then it will hit directly OpenAPI. Then, sorry, OpenAI API. Then you will get that response. You will start streaming. But until you get that, you might be like 20, 30 seconds waiting without actually using the instance you are paying for on serverless. On Fluid, what will happen is that while you have that idle time, that you're not actually using the CPU, new invocations can come into the same instance and reuse that instance. Same as when you had a server. Back into reusing the CPU, being able to have process waiting, process then restarting, etc. Coming back to the node roots also. I think I went a bit too long there, but I think like it's cool to see how the industry was pushing for this change and how we've been like built on top of it for a long time. Here we have Javi, we have Craig. They've been working on years on stuff like streaming, on stuff like bytecode caching, and all of these improvements have been building up together until we ended up with sending multiple requests for the same instance. And then it was like, okay, this is not serverless anymore. We have a different contract with our customers. We have a different contract on how this compute is running. We need to bring something new. And that's how Fluid came to life. And yes, Doug has been working many years too. Sorry, I missed you. I think I'm doing a monologue now, so I will open to folks who actually build it.
You know what? I think you touched on something quite important there as well, which is that the AI workloads are like really, really heavily IO bound. And they're the kind of workloads that with serverless become really expensive really quickly because you're paying for, like a lot of compute power that is all spent waiting for things to happen. And actually that's where like we see Fluid, it's one of the areas we see Fluid do really, really well, is that we're able to kind of optimize really heavily, stack a lot of requests into the instances where it's doing these really long IO periods. So things like, V0, we see like huge amounts of cost savings for swapping to our Fluid compute model.
Yeah, for a long time we were following the advice that we need websites need to be snappy. We're serving websites need to be snappy. 100 milliseconds is kind of the the traditional target, isn't it? It's like if you don't respond in 100 milliseconds, people lose interest. So we were optimizing for sort of double-digit millisecond response times, and with the AI APIs, that's just simply not the case. It can be thousands of milliseconds.
Yeah, what I wanted to also say is something that I recall every time that we talk about Fluid, which is that this actually, like you mentioned, Mariano, that we've been working on this for a very long time, like years, right? But what is interesting is that the whole development of Fluid felt, to me at least, like very organic. Like we started doing streaming solution on top of a traditional serverless implementation. We used to have in Vercel many limitations that were shared with many other like serverless providers. Like we have a limited amount of logs that you can return after an invocation. They are not live. They have to be received after the invocation is done, and many others. There are many other examples. But when we started building streaming, which is, by the way, documented in a blog post from back in the day, the one thing that I felt it was very interesting is that we opened connection channel between our infrastructure and the instance itself that was running the code. And we leveraged over time that connection very heavily, which becomes like the enabler for all of these things that we've been landed during these last couple of years, like real-time login, unlimited, theoretically unlimited login, bytecode caching, and now compute, which makes a ton of sense. But there was like a lot of development on the back that evolved since a very long time, and I think it's very interesting. It's an evolution, like quite literally. It's not something that we sat down and say, let's make this happen, right?
Yeah, I think that's great. I'm seeing like one question from Pauline about why isn't fluid compute enabled by default. I can take this one. The main reason is because, as Doug showed, now we have multiple invocations sharing the same instance. So now there are many things that are shared, as for example the global state. So we cannot turn it on for everyone, because retroactively we don't know if you were using serverless in a way that you were assuming you had one invocation per instance. So you might have some mess up. This has not happened a lot. I think like over 3,000 customers we had during the beta period, we only got 3 customers who got issues with it. And it's like really easy to fix. Usually it's just adding some boundaries, not declaring your global variables in your functions, and that's it. You are good to go. But that's the main reason, because we are changing that behavior. Anything else you want to add, folks, regarding to why it's not on by default? You're on mute, Craig.
One of the most common issues we've seen is database connection pools. And people have, under the service paradigm, you can't have more than one request at a time. So they've set their database connection pool limit to 1. If you have 2 requests at the same time and there's a limit of 1, the second one has to wait till the first one's finished. And generally speaking, it doesn't release the connection until the request is done. So effectively what you've done is serialized the requests there. So that's something really easy to fix, because you just make the number bigger. I think we have an open question of how big, but 1632. Just basically allow it to open more as it needs to, and that'll immediately solve the issue there.
Yeah, I think like those are the main cases, but they are, as you mentioned, they are easily fixable. So I think like the way that people need to think about Fluid is the same way that you can think about any node server. This runs exactly as it runs in your local server when you're running Node. It runs exactly as it used to run before going into the whole serverless era. It's like You just keep that model in mind. You keep the model that notes it single thread, but when you have I/O, it will free the thread and then process something new, and then you are good to go. There is not that much of a change. I would say over 98% of the code should be safe to just go, click enable Fluid, and have it running for you, have it making you any savings. And that's a great question on the chat about does it cost Vercel more or less? It's cheaper for users. The thing is that you keep paying for the gigabyte hours that you're using. So if your workload, we can compact it. If your workload has concurrency to fill more than one invocation or an instance, then you will be immediately saving, and that savings are passed directly to you because you're using less gigabyte hours in total. That's a way that you should think about it. You're still paying for what you use, and you are closer to being paying for what you compute rather than just paying for all of the idle time, because you're being more effective on how you use the resources you are paying for.
I think there's two things we kind of touched on, right? And one about like the defaults, and I think we will in the future make it the default for new projects. Obviously, we won't do like a breaking change for existing projects to turn on Fluid, because we don't know if you have these like weird edge cases in your code. But for brand new projects, we will make it the default at some point. Yeah, I can't remember what the other thing I was going to say is. I'm so scatterbrained.
I think you were going to talk about the new defaults, because that's another big change. Now we have new defaults that I would say are better defaults for everyone on Fluid Compute. Do you want to get into it?
Yeah, so I guess we've talked a bit about like how the efficiency kind of is a hell of a lot higher than in the traditional serverless model. And one of the cool things we are able to do because of that improved efficiency is change the kind of project default settings that we have. So if I just flick to like Vercel here, and I look in a existing project, right? If I come into settings and then functions, this is where Fluid Compute lives. But there's a couple of things to call out. That here, function max duration, it has a default of 15 seconds. And function failover is off by default. Function failover is like an enterprise thing to automatically fall over. If I turn on Fluid Compute and hit save, you'll see here that the max duration for my functions is no longer 15 seconds by default. It's now going to be 90 seconds by default. You would think on the traditional serverless model, the reason we've brought it all the way down to 15 seconds, obviously you can increase it up to 900, so 15 minutes on enterprise. It's lower on pro and hobby by default, is to prevent this scenario where we have like what we call runaway bills. That is that, as I say, you have a web application and you have your APIs. They take a request, they make an outward call to a database, they get data back from that, and then render some React component and return that to the UI. Now, if your database goes down, what can very quickly happen is all of those functions start to time out. So they hang for 15, 30, 60, whatever, however many seconds, waiting for that database to return data, because the database is overloaded or something else is wrong with it. And in the traditional serverless model, just jumping back to the demo if I can, you're paying for every single one of these for the whole time they're running. So if your database times out and all those durations shoot up, your costs also shoot up dramatically. And you can imagine if this is a really high number, say it's 900 seconds, if my database usually responds within 1 second, suddenly it goes down, everything takes 900 seconds, my bill is going to multiply by 900 times. Now with Fluid, that's not the case anymore. I say that because what will happen is it doesn't actually matter if your function's stuck waiting for your database, because we can just slot more work into that kind of idle time that the instance has. So what effectively happens there is that you can just add more and more requests. They all get stuck waiting for I/O. and therefore, the CPU is available and it can serve more traffic. And that means, we can stack this thing up really efficiently, and your costs don't skyrocket to the same extent. So in doing that, we can increase this to a much nicer, higher value, something that'll work better for most people. If you're doing AI workloads or something, long-running API calls, 15 seconds can be too short. So we're increasing that to 90 seconds by default, which should be better suited to people, and will not have the issue of those runaway bills. The other nice thing we're doing is we're turning on function failover by default. I think, correct me if I'm wrong here, Mariano, but I think that's enterprise only.
Yes.
Yeah, but the reason for that is when Vercel was created a long time ago, function failover didn't exist. And function failover, just to spell out what that is that if one of the regions go down where we serve your Vercel functions, if function failover is enabled, those functions will be served from a different location, the nearest geographic location to the one you've chosen to deploy them in. So talking here, if I am in, say, Charles de Gaulle, CDG, I think the nearest to that, Paris, France, will be Frankfurt. So likely the failover region will be, okay, Paris, France is unavailable. So my functions are going to run in Frankfurt rather than completely failing to run. So that's function failover. What I was saying is that wasn't on by default before, because a long time ago that setting never existed. We've never had the ability to turn it on by default. With enabling Fluid, we basically taken the opportunity to say, we think this is a good setting for most of our large enterprise customers to have on by default. While the opportunity is there, we'll make that on by default. And, with the benefit there that it will improve people's stability in the very, very rare instance that a particular function region is unavailable.
Two things I want to highlight also for Pro is, one, you are moving now. If you turn Fluid on, the max duration that you can set goes from 300 to 800. So now you can have a longer duration on your functions. This is mostly because as it will be reusing instances and being more efficient, you can be sure that you will not get into those runaway bills, as Doug explained. I think that's something cool. You have extra 500 seconds now to set. And the other thing is, in Pro, you don't have function failover on region level, but you still have it on availability zone level, if that makes sense. Each region has multiple availability zones. So to have a region going down with all of the availability zones going down, it has to be like a really bad incident. Just want everyone to be sure that this is not something that, happens every Tuesday.
Yeah. So just showing the same thing for a Pro team that I have here. In the in the serverless model, my function max duration is limited to 300 seconds. And the default, again, was 15 seconds. But if I enable Fluid and hit save, you'll see that my maximum is now 800 seconds rather than 300.
Nice. Best Codes is asking if there is like any even quite obscure breaking change on switching from serverless to Fluid Compute. I think we've gone through the two breaking change, that is, you are using global state and you're sharing it across multiple invocations, so you might have some weird results. And the databases one that Craig went through, I don't know, Craig, if you want to go deeper into the share state and maybe give like a quick example of you sharing a variable.
Yeah, sure. We've been discussing this at the beginning, if it makes sense or not, to try to keep this isolation semantics, and it doesn't make sense. And we will be going through basically the same thing that we have had before, that is very inefficient and it's like against the way Node.js actually works. So what I feel there that is very interesting to also share is that this is precisely the reason why it is not enabled by default. I got that question in the past, and it's like, in general, it shouldn't break your code at all, but it can happen because there is an underlying semantic that is changing. And the typical example would be if you have, for instance, say a function where there is an object on the global scope, and then the function handler is asynchronous. So you read the value at the beginning of the function, then there's an asynchronous operation, and then you update based on what you read. Like, for instance, say that you have a counter. You read at the beginning of the function, you wait for 1 second, and then you update the counter based on what you read before. In a traditional serverless model, you would always have unique access to that object that is in the global scope, because it's not going to be shared. There are not going to be any functions running and competing to access that resource. So there's not going to be any race condition. There's not going to be a problem when you're writing there. However, if you enable Fluid and you are doing this kind of thing, then you can have how you say it, like you're gonna have these concurrency issues. You're gonna have these race conditions. In normal circumstances, though, this shouldn't happen because people usually don't program their application with the assumption that this access pattern is what you're going to get all the time. Mm-hmm. Usually when you're running the server in your local environment, for instance, you have like a normal, regular server. It is true that you are not getting the concurrency level that you can reach when you are hitting production, but semantically it works in the same way. So it's not very usual that you get to have a problem like this, but it's possible if you opt into Fluid, which, like I said, is also the reason why it is not enabled by default.
I have a question that's kind of along those lines. Is there any kinds of workloads that benefit more? So kind of the other side of what problems might someone run into? What kinds of workloads benefit the most?
Definitely. Craig. Yeah. Craig, want to answer that?
Yeah, Ben, the workloads will get most benefit from this are the ones that effectively do the least. So the reason we bring up AI workloads is that in most cases, your application wouldn't be doing any heavy crunching of its own. It would be offloading to OpenAI's APIs or similar, Gemini or Meta or whoever, and that's where all the number crunching will be going on. So your application is effectively doing nothing at that point. It's offloaded the request and now it's just waiting for the response. And the longer it waits, the more reuse we can have with Fluid, because there's more space in that function CPU availability for us to slot more stuff. So effectively, yeah, the stuff that will benefit least is when you are doing something quite heavy and you're maybe not doing any I/O at all. So maybe you're fetching a result set from a database, but then you're doing a lot of in-memory transformations on it. Maybe calculating stuff, doing meshes and stuff like that. Lots of CPU utilization. They won't benefit so much because the node process will spend a lot of time blocking the event loop doing this busy work. So yeah, it's IO bound loads. So if you're fetching from a remote API, database, anything sort of outside of the instance itself, there'll be huge benefits, and that is the majority of workloads. Very little of the time is actually spent doing number crunch and rendering. Most of it in our observation is spent waiting for third-party things.
Yeah, and I think like something really important to remark there is that not getting benefits means you are running as you were running up to now. It's not that you are getting it worse. Like in the worst case
scenario is exactly the same as it was before. Yeah,
exactly.
Effectively with Fluid, you can run multiple invocations at the same time in an instance. If you can run 3, 4, 5, 10, 16 invocations at the same time, that's great because you're making huge savings. Worst case is that you can run one at a time, but that's just traditional serverless, so you're no worse off.
And so if somebody enables Fluid Compute, does that go live immediately, or do they need to like create a new deployment before that really takes effect? Does it affect past deployments or only future?
It only affects future deployments. So once it's enabled, you will get a prompt. Once you enable it, you'll get a prompt to redeploy your most recent production deployment to turn it on. And so you just click the button in the window and it'll do the thing. The reason for that is primarily because that way you've got this level of control. You can do maybe an instant rollback. You know, if you find, oh, I don't like it, it's broken something, we've found a race condition we didn't know we had, instant rollback, you've got your previous deployment, everything's good. So it's sort of a level of safety net there, because it is, you know, it's
Nice.
something very.
So you would
very
just
different.
have to roll back if you found yourself in
Yeah,
that kind of edge
instant
case
rollback
where it didn't work.
takes a second, and you're back to how you were.
Yeah, you can also for example turn it on, play with other settings. Let's say you are, I don't know, hospitals in France, just really edge case. Hospital in France, they cannot run their compute out of France. So you turn Fluid on. Your function failover is turned on by default, but you don't want that because you don't want to fail up to Frankfurt if Charles de Gaulle goes down. So you go, you turn it off, and then you redeploy, and you will have your deployment with Fluid, but not with function failover on. So you can fine tweak stuff and then redeploy when you feel safe with the new settings. Another use case is, hey, I prepare everything and then I push a new preview deployment because I want to check something on preview. I want to see, hey, are all of my tests going through? I want to play a bit with it, see how it feels. So you can go, you turn it on, you set everything, you deploy a preview, you can play in the preview, and once you feel ready for it, you deploy your new production deployment.
So you mentioned kind of being able to control the failovers. How much other granular control? I'm sorry, you can probably hear my dog growling. How much other like granular control do you have over things like failovers? Maybe turning it on for just specific environments or turning it off for specific environments. Maybe manually adjusting concurrency. I'm going to go on mute because my dog is growling. So sorry.
So Mario, do you want to?
Yeah, I can take it.
It's kind of your thing, this one.
Yeah, no, you turn it on for the whole project and you forget about it. And then each of the different settings, you can modify them as you could do it before. Like, for example, max duration, you can still go into your Vercel JSON or into your functions and have a custom max duration for each of your path. Then regions, you can go and pick whichever regions you want to deploy to in the UI, or you can do it on Vercel JSON. All of that configuration remains the same. What is global to your project is being running on Fluid, which means we are handling multiple invocations on one instance.
Yeah, part of the kind of the idea behind this the Fluid specifically sort of branding as Fluid rather than, because like before we had IFC, which was just referring to the concurrency part, but Fluid is more than that. It's effectively, we will do the right thing for your code. You know, just we'll sort it out. It means that you essentially don't need fine-grained control normally, unless there is some, you know, as you say, Mariano, if there's a regulatory reason, you can do it, but normally you wouldn't need to.
Yeah, the idea is we are going into a world with no configuration, and that's where we are heading to. You should always be able to have your configuration for regulatory reasons and stuff like that, but we want you to be focusing on building your product, on solving the problems that you want to solve. We don't want to have you figuring it out of, oh, if I forget this max duration on 35 seconds on this function, I will go broke, because if I have my database failing, then my bill will run away 35 times what it was costing before.
It is also very easy to misconfigure, right? Like one thing that we have seen a lot is that some customers just try to, just for the sake of trying to save some money, they enable a very low memory configuration for their functions. And effectively, what happens with this is that the VM is trying to schedule the CPU and artificially limits the amount of CPU that you have access to. So what happens in the end is that if you allocate too small memory, the event loop is going to be blocked as soon as you try to use too much CPU, which is the normal case when you have, for instance, a code boot, which is not very common nowadays, but still possible, especially if you're using Next.js and we are bundling multiple paths into the same function. When that happens, if your configuration is suboptimal, what's going to happen is that you're trying just to save money because you think that it's going to perform just fine, and it ends up costing you more money because the time that the CPU get paused is also paid, right? So you are like literally, by limiting the amount of memory, you are limiting your function quite literally. But while you are limiting it, it is also costing you money because it is paused and waiting to get some CPU so that you can keep scheduling work and finalize the execution.
Yeah.
And this is not something easy to get, right?
And not just money, it's also costing you time for your customers, time that your customers are waiting for the response. We've had like a lot of cases of people that were like, hey, I was sitting on basic, that is 0.6 CPUs and 1 gigabyte of memory. Then they bump into standard, that is 1 CPU and 1.7 gigabyte of memory, and added Fluid into the mix. And suddenly you will say, oh, so now I'm paying 70% more. No, because your workload is going faster because now you have a whole CPU and 1.7 gigabyte of memory. And also now you are reusing instances. So they ended up having a cost reduction of about, I think this customer was having cost reduction of 25% on top of responding to customers around, it was 35-40% faster. So they ended up paying less and being faster. Win-win.
I don't want to put you on the spot because I know you might not have this just right off the top of your head, but what kind of cost reductions have you been seeing with, early beta and all of the, early launch?
Sorry, can you repeat the question? I think I didn't get it.
Oh, sure. Just what kinds of like cost or usage reductions have you seen?
Oh, yes. We've seen up to 85% savings on regular days for customers. This is for customers who have been like really, really IO bounded. Then in average, we see a lot going around. It really depends on your workload. Like for example, B0 was sitting at around 66% of savings of reutilization of instances. Then you have other customers. For example, we've seen runaway bills nowadays that in the past would have costed you a lot of money, that because they are reusing the same instance as Doug was explaining before, they are getting 90%, 94% savings while their backend is timing out. So those are also savings that we are seeing. It really depends case to case, customer to customer, workload to workload. But yeah, you have nothing to lose by turning it on. Sorry, Craig. Go ahead.
So the workload, there are two factors to the workload. There's the IO boundedness, so how much work it does in the function versus how much it offloads to a third-party API or database. And then there's the request rate as well. So obviously, concurrency within a single instance requires the two requests to be happening at the same time. And what we've sometimes seen is that the people who have got quite low savings simply don't have enough traffic for two to overlap. And in that case, we serve one and then we serve the other, and they pay for the whole time of both of them. So, but even if you're hitting 5 or 10 requests per second, then your savings ramp up really fast.
And, because anything is possible, have you come across any cases where cost did go up for anyone? Or, has it been all neutral or cost savings?
No, it's been all neutral or cost savings. It's because of how it works. Like it cannot go up because in the worst case scenario, as Craig mentioned, you will be doing one instance per invocation. So you are back
just the
into
same
what
as-
you were before.
Yeah.
That's awesome. And how does Fluid Compute compare with something like AWS Lambda, Cloudflare Workers, or other compute platforms that people are using in a similar kind of way?
The short answer is right. It's just better in every way.
Yes, it takes the best of all of those, puts them together.
That's the thing. You're getting the best of both worlds, right? Like I would say that Cloudflare Workers, for instance, it's cool, but they're also cheap, right? If you have, especially if you have IO bound workloads. However, you are limited to a runtime that, in our experience, is really harmful for people. Some people just want to
The
use
lack of
their
node
modules.
compatibility. Yeah.
Exactly. But especially because like maybe you want to use a module, and this happens a lot in Next.js. Like you're using a specific module because you want to use a specific functionality from this specific module, but it turns out that the dependency tree implies using something that is native from Node.js. So the way Next.js is going to behave is going to say, hey, if you deploy this as an edge function, this is not going to work in production and just fails when you try to deploy this. And what we learned is that people just want to use their modules, man. They just want to use Node.js modules at a single runtime, and they don't want to be thinking about using a smaller runtime just so that their function can run in a specific platform because it's better. It's like theoretically faster, or you have a better billing model or whatever. They just want to use Node.js. That's all, right?
Mm-hmm.
So in this case, with Fluid, you can just use Node.js and still have some savings, or you can still make like an adequate platform for when you are running or you want to run AI workloads.
Yeah,
I know you mentioned Node.js, but it's probably worth calling out that we support Fluid Compute on Python as well.
Thank you.
And there's
That's a good
potentially
call.
like other languages coming in the future.
Yeah.
It's not
That's a great call.
specific to Node.js.
This
Yes.
is
My
a
next
Node.js
question.
technology. This is optimized for Node in the first place.
Yeah, exactly. This is a new compute model that you can run any runtime that we are going to be adding on top of across time.
Mm-hmm.
This is also an open specification, so we are opening it to other people to go with their own implementation of Fluid. The vision for Fluid Compute is out there. Right now we have our own implementation, but happy to see what other people make of it. And I think at the end, what we are trying to close here is this gap. You always have like this trade-off between the DX and the efficiency, the performance. And we are trying to close that gap and be able to get the best from both worlds, because we think we can do it. We can push the web to be a better place and have a great DX, have a great experience, have a great efficiency, and make everything into the right direction.
I think that's, so going back to your question about how does it differ to other platforms, e.g. Lambda, e.g. Cloudflare. So the difference from Lambda is that Fluid is optimized for serving the web. Lambda is a general purpose compute platform that incidentally can be used as a web server. Whereas we've really locked down and optimized for the workloads that people want to do while serving on the web. So
I'd maybe caveat that and say like it's not necessarily like web workload specific, but I think it's just kind of like an inherent implementation of Lambda that they kind of have the like one request per VM level isolation.
Yeah.
And it's kind of always been that way because it's quite hard to have like the right load balancing, the right systems in place to make sure you could route traffic kind of dynamically to existing instances and so on. That's why we spent years trying to build that. So it's not necessarily like a more web specific version of that. It's just that Lambda's like that isolation that makes it inefficient, and we don't have that.
Yeah, and I think like that kind of answers to the question from Best Codes in the chat about what would AWS criticize about Fluid Compute. I think this is not something to criticize about. This is just, we have different models that we are hitting different use cases. Like you have a use case for serverless, you have a use case for Fluid. For example, for AI, serverless was not working great. It was not working great internally for us with V0. That's why we had to go and build Fluid. Then there are other use cases, other workloads that Lambda will be the right option to go probably. So this is just us pushing the web together to make it better.
And this is just as a infrastructure, because then there are all of the side goodies. Like for instance, I mentioned before that when you are using Lambda, they have like great observability, but you have to go there. You have to go to their to configure like watchlog and then check there what happened to an invocation, and you get the events after the actual invocation did happen, right? Well, then I'm not sure. I'm not positive about that part though anymore. But the ergonomics that we are building with all of these are generally better in our experience, and we are a smaller animal, so we can move faster. Lambda, for instance, when we prepared streaming, when we introduced streaming into our serverless platform, that wasn't a thing in Lambda. We get ahead of that. And in our case, in Vercel functions case, it was pretty natural because we have the signature of our functions is based on the request and the response. So it felt very natural. You just need to use Node.js as you would typically use it. Like the only difference is that the server is not going to buffer the response. However, in Lambda, you have to have a different way of consuming their APIs to respond. You have to have sort of an adapter because it's not like request response, right? It's like an event.
Yeah, it's probably worth calling out as well, right? Like with Fluid, you get all the kind of Vercel DX benefits that we've always had on Vercel, whereas it's not like all the manual provisioning lambdas, managing their life cycles, deleting them, like, I don't know, preview environments, all the kind of like crazy stuff that you'd have to do if you wanted that. I know there's maybe like another kind of sneaky answer in that, like, what would AWS criticize about Fluid Compute if you were to ask them? And maybe one thing they'd say is that like you can't run it outside of Vercel. And that's just because like we manage the infrastructure that has the algorithms, the load balancing, all the logic in place to route requests to the right place and to abstract all the complexity. And like it makes sense for us to build that infrastructure because of the scale at which we run. But like it doesn't make, AWS is like a much more bare bones platform than Vercel. And like it doesn't make sense for, individual people hosting their, websites or hosting their applications on AWS to build the infrastructure that we've had to build to make Fluid possible.
Yeah, it doesn't scale down to single projects.
Yeah, but again, going back to what we were saying before, we are open, like Fluid is a concept that we are opening to the world. So
yeah,
they could, and we would be happy to have it in more places.
That's awesome. I think it's great to be pushing things forward for the web because it makes it better for everyone. So
Yeah.
it has to start
And
somewhere.
talking about that, quick shout out to Google Cloud Run because they were doing concurrency, like multiple requests running on the same instance before, and that's part of where the inspiration and foundations come for Fluid. So just want to recognize that it's not everything just AWS or Vercel or whatever, like many players who are pushing the web forward. And that's happening from every place. Like we have so many flavors of serverless around because it's the flavor of serverless that you get from AWS is different than the one you get from Azure, or the one that you get from Google. And in each of those places, great things are happening and people are pushing it to its best.
One final question. Are there any upcoming features planned or maybe upgrades for Fluid Compute?
Keep tuned to the Changelog channel.
Fair answer. Is there anything else that you guys want to share before we sign off here?
I think only go there, turn it on, start playing with it. I think it's also worth it to mention, go there, start using also the Node.js experimental middleware on Next.js 15.2. It will also be running on Fluid, so you don't have to worry too much about it. And yeah, just have fun.
There's one more thing that I want to say. It's gonna be much better. Like, this is a great product, and we think it's like super cool, but it's still the enabler to bring new stuff. So yeah, more things are coming that are enabled thanks to Fluid Compute. So yeah, don't miss it.
Yeah, we are just starting. This was the first iteration towards the Fluid Compute vision.
Yeah.
Awesome. Doug, Greg, anything else you want to add?
No, just thanks for having us.
Awesome.
Yeah, thank you for having us.
Thank you all for
Thank you.
being here.
Summed
This
it up
was a
nicely.
great talk. I really appreciate you taking the time. I just want to say thanks again for everyone who joined in the chat as well. Fluid Compute is available now. Try it out. Please come and let us know what you think. And then remember that next week we will hear from Noah at What AI Idea. He's going to talk about how he's using V0 for his business. And we have quite a few others. You can find them all in the community events calendar. And thanks again. We'll see you next time.